Good day everyone. I am Trisha May Aragon, a BSE student. Today, I will be discussing an AC circuit using nodal analysis based on figure 4.7 from Electrical Circuit Analysis by Johnson Johnson and Hilburn. As you can see, this is the given circuit diagram. The objective of this problem is to find the current using the nodal analysis method. So first, I assign the nodes. So node 1, node 2, node 3, node 4. It is also the V1, V2, V3, and V4. So the value of our V4 is equal to 0. And then we also define the direction of the currents each impedance. So A, B, C, D. And the I here is the current that we need to find. So here, using the nodal analysis. I also converted all given values from rectangular form to polar form for easier calculation. So KCL at node 1. So this is the node 1. So our equation here is so what are the current going in our node 1? So 2 angle 20. So 2 angle 20 is equal to going out to node 1, which is the A and B. So A plus B. And our equation now is A plus B is equal to 2 angle 20. So for our A, this is the equation since A. So V1 minus V4. So V1 minus V4 all over the impedance here, which is 6.083 angle 9.462 plus the B. So our B is V1 minus V2 all over the impedance here, which is the 3.162 angle 14.435 is equal to 2 angle 20. So here we will cancel the V4 since it is already 0. So we will compute in the calculator. So our V1 is 0.479 angle negative 15.369 V1 minus 0.316 angle of negative 18.435 V2 is equal to 2 angle 20. So this is the equation 1 now. So next is KCL at node 2. So at node 2, our equation is so going in B. So B is equal to going out C and I. So C plus I. So the equation now is B minus C minus I is equal to 0. So our B, V1 minus V2 all over the impedance here minus C. So V2 minus V3. So V2 minus V3 and all over the impedance there. So minus I. So V2 minus V4 all over the impedance here, which is the 2.236 something. So it's equal to 0. So we will compute in calculator again, and our V4 is 0. So we will compute in calculator. So this is our equation 2 now. Next is the KCL at node 3. So KCL at node 3, going in, so C and D. So C plus D, and the going out current, which is the 2 angle 20. So C, V2 minus V3 all over the impedance here plus D, V4 minus V3 all over the impedance. So it's equal to 2 angle 20. So compute in the calculator, and this is the equation 3 now. So we have 3 equations now. So here 1, 2, 3, and we still need 2 equations. So from equation 1, we can get the V1. So from the equation 1, B1 is equal to 2 angle 20 plus, we will transpose this on the other side, so plus 0.316 angle of negative 18.435 B2, and divide both sides by 0.479 angle negative 15.369. So compute in calculator, B1 is equal to 4.175 angle 35.369 plus 0.660 angle negative 3.066 B2. And this is already the equation 1 prime. So next is from equation 3. So V3. So V3 is equal to 2 angle 20, and this we will transpose it in another side. So negative 0.110 angle of negative 6.340 V2 all over the 0.425 angle 164.687. So compute in the calculator and we can get this equation now. So this is the equation 3 prime. So from this equation 2, 1 prime and 3 prime, so we can substitute the equation 1 prime and equation 3 prime to equation 2, since ito na lang yung hindi nagagalaw sa mga equation natin from here. So sa equation 2 natin sila i-substitute. So equation 2, 0.316 angle negative 18.435 V1. So our V1 is here, our 1 prime, so we will substitute it, plus 0.868 angle of 158.916 V2 plus, copy ulit, 0.110 angle negative 6.340 V3. So our V3 is here, the equation 3 prime. So you will put there. So next is to simplify further for us to get the value of V2. So V2 na lahat yung mga nandito. So yung V2 ilalabas natin. And we will simplify it. So 0.316 angle negative 18.435, we will multiply it to the V2, which is the 0.660 angle negative 3.066 plus, copy the V2 here, 0.868 angle 158.916 plus, we will multiply again 0.110 angle negative 6.340 to 0.259 angle of negative 171.027 V2. So here, so this is the V2 now. Next is equal to the constant. So 0.316 angle negative 18.435 multiplied it to 4.175 angle 35.369. So here, minus 0.110 angle negative 6.340 multiplied to 4.706 angle negative 144.687. So here, so it is already simplified. I mean, it is already naayos na siya. Mas madali na siyang isolve sa calcu. So we will solve this. So 0.633 angle 158.017 V2 is equal to, we can compute it to the calculator, 0.820 angle negative 170.631. So our V2 now is 1.295 angle 31.352. So from here, we can now get the current. We can now get our current from here, since we already compute the value of V2. So I is equal to V2 minus V4 all over the impedance here is equal to, substitute the V2, so here, and the V4 is already 0, all over the impedance, 2.236 angle 26.565. So our I now is 0.579 angle 4.787 amperes. So this is the answer. That's all for today's video, and I hope you've learned something from me.